Hello, everyone. In the previous lesson, we learned 1. The knowledge and the application of electric power. 2. 3 working states and the best working state of electrical equipment. 3. The measurement of electric power. You have learned that it can be measured with a special high-precision instrument, the D26W power meter. In this lesson, we will learn new content to install the house lead-ins. In the previous lesson, we had a tabular task in the implementation methods and steps. Assuming we're renovating a new house, how would we complete the selection of the main switches and wires? In this lesson, we will further explain installing the house lead-ins. In this lesson, we will learn 1. Selection of main switches and wires and 2. Installation of house lead-ins. Let's continue from the previous lesson. 4. Selection of switches and wires. First, let's focus on the selection of the main switches. To choose the main switches, we must first know the electrical load situation of the residence and select the appropriate switches, equipment, and wires based on the load situation. General loads, household appliances, such as lights and refrigerators, are divided into two types: resistance loads and inductive loads. The formula of resistance load power is P equals UI. The formula of inductive load power, such as a fluorescent lamp, and the power factor of fluorescent lamp load are as follows. Different inductive loads have different power factors. According to the experience, the power factor can be used to calculate household appliances, and the unified value is 0.8. That is to say, if the total power of all appliances of a household is 6,000 watts, the maximum electric current is as follows. Usually, household appliances are not used simultaneously. Therefore, add a demand coefficient of K, and the demand coefficient K of single-family housing generally equals 0.5. So, the above calculation shall be rewritten as follows. So, this household's total electric current value is 17A, and the main air switch shall be greater than 17A. For example, according to the listed power ratings of the devices in John's household, the simultaneous power consumption of John's household is calculated as follows. John's household shall choose the main switch air switch greater than 14.7A. Let's move on to the selection of wires. Generally, 2.5 square millimeters shall be selected according to 6A per square millimeter or the load current value, part, of wires stipulated in the Chinese Standard GB 4706.1, 1992/1998, as shown in the table below. 5. Installation of house lead-ins. The house lead-in is the connecting device of indoor and outdoor lines, and is the power lead point of the internal line of low-voltage users. The house lead-in device comprises a service entrance pole or a porcelain insulator installed on an angle steel support, a house lead-in, a connecting insulated wire from the first outdoor support point of the user to the first indoor support point, and a service entrance pipe. A part of the house lead-in is outdoor, and the rest is indoor, so bare wires are not allowed. The general requirements of the house lead-in device are as follows. 1. Where the service entrance point is higher than 2.7 m or the service drops are raised due to safety needs, the service entrance pole shall be installed to support the service drops and the house lead-ins. Concrete poles are generally used for service entrance poles. 2. Before installing concrete service entrance poles, check whether there are bends, cracks, and looseness. Refer to Table 4.1 for the depth of concrete service entrance poles buried underground. 3. The top of the service entrance pole shall be equipped with a crossarm, which is usually made of galvanized angle steel, and the distance between the two insulators on the angle steel shall not be less than 150 millimeters. 4. The house lead-ins shall adopt copper core or aluminum core insulated wires with good insulation and its cross-section. Copper core shall not be less than 2.5 square millimeters, and aluminum core shall not be less than 10 square millimeters. No joint is allowed in the middle of the house lead-ins. 5. When the house lead-ins pass through the wall, the service entrance through wall sleeve shall be installed to protect the house lead-ins, and it is better to use the elbow sleeve. There are many service entrance sleeves, such as porcelain, steel, and hard plastic pipes. To avoid crushing the porcelain pipe and damaging the wire's insulation, only one wire is stipulated for one porcelain pipe. When steel pipes or hard plastic pipes are used, all house lead-ins shall be threaded into the same pipe. The total section of wires, including insulating layers, in the pipe shall not be greater than 40% of the effective section of the pipe. The minimum pipe diameter shall not be less than 15 millimeters of the inner diameter. The wall thickness of steel pipes shall not be less than 2.5 millimeters, and the wall thickness of hard plastic pipes shall not be less than 2 millimeters. 6. The service entrance sleeve shall be smooth and unblocked, and the part of the pipe extending out of the wall shall add waterproof elbows. The content of this lesson has been fully presented. Let's review the key points of this lesson. 1. Selection of main switches and wires. The key to selecting the main switches is to select the pass-through electric current value according to the formula. When selecting the main switches, calculate the electric current value and ensure it is greater than this value. The key to selecting wires is the pass-through electric current value, which shall be 2.5 square millimeters according to 6A per square millimeter or selected according to the reference table. 2. Installation of house lead-ins. According to the general requirements of the house lead-in device, it can be installed according to the requirements of 6 points. That concludes this lesson. Thank you, everyone.